Look at the notes now, and I want you to follow with me as I read the notes on tape 330, Graphing Algebraic Functions. Okay, step 1, find the x-intercepts. That means find where it crosses the x-axis. Or when it crosses the x-axis, y0. For instance, let's look at a graph right here. Finding the x-intercepts would be where it crosses the x-axis, which is when y is 0. So what we do is set y equals 0 and solve for x. Alright, now to find the y, step 2, find the y-intercepts, then what is x right here? X is 0, so we let x be 0 and solve for y. So the first thing to do, it doesn't make a difference which order, step 1 or step 2, is to find where it crosses the y-axis and find where it crosses the x-axis. Now listen, to find where it crosses the y-axis, you let x be 0, and that's the easy one. You just let everywhere the x is, that's 0, and whatever's left, that's what y is. That's where it crosses the y-axis. Then you come back and let y be 0. Now when you let y be 0, then you're having to solve an equation in terms of x. But when you do that, you're finding where it crosses the x-axis. Alright, now look back at the notes. Step 3 is to find the vertical asymptotes. Vertical asymptotes. Well, let's see. Vertical asymptotes will be a dotted line that we'll draw up and down here. And a lot of times when you calculate it, when you graph a function, it'll come up here and it'll come up all here, and all of a sudden the line will go straight down. That line really isn't part of the graph. That line really isn't there. What happens on the calculator, it has to connect the last dot it had here to the next dot, which goes down here, and so it connects with the line. But what happens if you have a denominator in a function, then that ends up being an asymptote most of the time, and that means that's a dotted line there. Okay, so that's the vertical asymptotes. All right, horizontal asymptotes now will be a dotted line going this way. And we'll discuss how to find those as we go. All right, now let's look at example 1. Example 1 says that we have the function y equals x to the 6th plus 7x to the 5th plus 12x to the 4th minus 14x cubed minus 59x squared minus 57x minus 18. We must, step 1, set the y equal to 0. Solve that. Well, that means we have to solve that. Well, one way of doing it on pencil and paper is what's called synthetic division. You should know synthetic division. If you don't, there's a videotape on it. Okay, or you can get an algebra book and look at it, but here's how synthetic division works. You write down the coefficients of the x's, and if any one of the powers up here is missing, you put a 0 there. If the x squared had not been there, you put a 0 in that place. Don't move these numbers together. You need a coefficient for every power of the x. So you write down the coefficients. Then you come over and try the factors of this constant. The factors of this constant, which is plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 6, plus and minus 9, plus and minus 18. All right? So I'm going to start off with the plus 2. So here's what you do. You copy the first coefficient down, and here you multiply, add, multiply, add, multiply, add. So multiply 2 times 1 is 2. Add is 9. 2 times 9 is 18. Add is 30. 2 times 30 is 60. Add is what? 46. 2 times 46 is 92. Okay. Add is 33. 2 times 33 is 66. Add is 9. 2 times 9 is 18. And if this comes out to be 0, that is a correct answer. Now, if this has not been 0, if I try to number and this has not been 0, then what I do is go erase all this, try another factor of 18. But it comes out to be 0, therefore that's one place it crosses the x-axis at x equals 2. That's one of the factors. That's one of the roots. Okay, then you try again. Now what you should try again is 2 again. Always, when you find one of these, try it one more time because it might work again. Now it doesn't in this case, so I'll try another factor. And this time I'll try minus 1. All right? All right, I copy down the first coefficient. 1 times minus 1 is a minus 1. Added is 8. Minus 8 added is 22. Minus 22 added is 24. Minus 24 added is 9. Minus 9, oh, we get 0. Good, there's another root. All right, so I try minus 1 again. All right, copy down the first coefficient. 1 times 1 is a minus 1. That's 7. That's a minus 7. That's 15. That's a minus 15. That's 9. That's a minus, ooh, great. Got a 0 again. So that one's another one. All right, so I try a minus 1 again. Minus 1, that's 6. Minus 6, that's 9. Minus 9, that's great. I got 0 again. So therefore, minus 1 is again. Well, then try minus 1 again. It doesn't work. So I quit. Try something else. Okay. Try minus 3. All right, that would be 1. Minus 3. That's 3. That's a minus. That works. Okay, minus. All right, let's try minus 3 again. Okay, 1 minus 3, 0. Works. Therefore, there are all my roots. Where it crosses the x-axis at 2, minus 1, minus 1, minus 1, minus 3, minus 3. Now, in the notes, I'm going to show you something. Rather than having, when you get down to the last 2, you can just take this and do it this way. This was x to the 6th to start with. We took out 4 roots, so this is now x squared plus 6x plus 9. X squared plus 6x plus 9. Factored is x plus 3, x plus 3. You set that equal to 0, and you get a minus 3 and a minus 3. So when you get to the very end, when you get this down to x squared, you can go do factoring in a quadratic formula or something like that to find the last 2. But you can also use standard division. All right, so let's look at this one more time now, and I want you to look at your notes too. Here's what I want to say to you. What you have to do first on this is to let y be 0 and go solve that. You have to go solve it. Now, there's several ways of solving it. If you look at your notes on the TI-92, if you have a TI-92, you can do F2, hit the F2 button, which gives you the algebra column, okay, on your screen. And then in 2, for 2 it says factor. So you can punch 2 factor and then enter this function. Then type in x to the 6th plus 7, x to the 5th. And so, okay, and then hit enter, and it does it. Now what it does, it gives this factor. Listen closely now, make sure you understand this. This will give you x minus 2, x plus 1, 3 times, and x plus 3, 2 times. So the roots are, change the sign. It's the opposite sign here because you're setting this equal to 0. So x minus 2 equal to 0 gives you x equals to 2. X plus 1 equals 0 gives you x minus 1, 3 times. X plus 3 equals 0 gives you x equals to minus 3, 2 times. All right? So that's how you, if you have a 92, this is great. You don't have to do synthetic division. You can just type that in as factored and it'll factor it. Now if you have an 85, if you don't have the 92, you have an 85, then the way to do this, to find these roots right here, is to graph that. Just that, okay? And see where it crosses the x-axis. That's great. So you just hit graph, enter the function, and then enter 0, enter minus 4, hit F5. Okay? And then try all the factors. Now what this hitting F5 and then trying all the factors of 18 is, what happens is on the graph sometimes your tracing won't be, you won't see this 3 times. You'll just see this 1 time. And you won't see this 2 times. You'll just see it 1 time. All right? And in fact, sometimes if you don't go try and get close to these, it skips over these that are to the even number powers. Okay? So you can trace and find some of these, but you won't find necessarily that it's 3 times or 2 times. All right? So you need to do that to find out how many times that same factor is there. All right, so that's just the beginning part. To find where it crosses the x-axis, you have to solve. You can use your solver if you want to. But solve for the roots of the equation. All right, now let's finally get to going through the steps and sketching it. All right, now we're back to, let's start over again, step 1. Step 1 is to let y equals 0 and solve for x. So that's what we did. So looking at the graph, step 1 says, all right, it crosses the x-axis at 2. Let me just make up some distances. 2, 3, 4, minus 1, minus 2, minus 3, minus 4. Okay, so here's what I want you to listen to real closely. Here's the trick to all this. 1 root is 2. It's 1 times 1 root of 2. So it crosses. So put an X there for crossing the x-axis. A minus 1, 3 times, odd number of times, an odd number of times, it crosses. So minus 1, it crosses. Minus 3, even number of times. If you have the same root 2 times or 4 times or 6 times, then it bounces, it touches, it bounces off of it. So over here put a circle. Okay, so for minus, 1, 2, 3. For minus 3, it bounces. In other words, it's going to come up here and bounce off, or it's going to come down here and bounce off. The crosses here, it means it's going to cross. Right? So keep that in mind. That's the trick. That's the deal that you don't usually see in textbooks. Okay? So if the root is an even number of times, the same root twice or 4 or 6 times, it bounces. If it's 1 time or 3 times or 5 times, it crosses. All right, so that's what we did step 1. We found where it crosses the x-axis. Step 2, where it crosses the y-axis. Well, we let x be 0. Well, when x is 0, it just wipes out all those x's. X to the 6th, that's 0. X to the 5th, that's 0. And it only leaves us the constant at the end. Okay? So therefore, it crosses at y equals a minus 18. All right? So, let's see. Cross it at y. Well, learn to, hey, we don't want to draw that way on down here because this may go down to 100 or 200. So what we'll do is just call this. Just make a point there and say, okay, this is a minus 18. So it crosses y at a minus 18. All right, now step 3 and 4 on this problem is not there. There are not any vertical asymptotes or horizontal. Vertical asymptotes and horizontal asymptotes only come if you have x's in the denominator. Only if you have x's in the denominator. So if you do not have any denominator in the problem, step 3 and 4 is out. You don't fool with it. All right, now look how simple this is. This is how simple this is. Once I know all this, I simply know here's part of the curve. So it has to cross, so it must come up here and cross. All right? And then it bounces over there, so it must come over here and bounce and then go out here forever. And then over here it comes down, and then it's got to come up here and cross somehow, so it goes out there. What I like to do is say, I use this step 2 just to help me know what's going on. I start from that point. Let's say, for instance, that this had been a positive 5. Okay? Then what I'd do, I'd start here, and I've got to cross, and then I have to bounce, so it goes out that way. Okay, some of this comes over here. It's got a cross and goes out that way. So what I do is I find where it crosses and bounces, and I find me just one other dot, just one other point on the graph. I don't have to use this minus 18. What I could do is plug a 1 in here. If I plug a 1, just let x be 1 in the original equation, I get a minus number down here. So it says it's down here. So from there I start here, and then I go back over here and bounce and go up. That's all there is to it. Step 1, find where it crosses or bounces on the x-axis. Step 2, find where it crosses the y-axis. And then, if you don't have a denominator, just go sketch it in. Now, you need to understand, when this is a sketch, not a graph, this is a sketch, not a graph. This point goes way on down there. If you put a 1 over on that curve, you get a minus large number. So this goes way down there. But here's the sketch. The sketch says, hey, it bounces here, so I know curve is basically looking like that. All right, now, while we're looking right at that, let's look at using the calculator. And if I were you, if you're looking at this tape, I would, if you don't have your calculator with you, I'd turn this off and go get your TI 85 or 81 or 92 or whatever and bring it back and check these out as we go. Because here's what I want you to see that I have in the notes. To graph this with the calculator, we can set the window or the range on the 85, the window on the 92. We can set the window at a minus 8 because the roots are somewhere between here and over here. We can put it at a minus 4 if you wanted to, and a plus 4, whatever. Minus 8 to a plus 8. Okay, minus 10 or standard. Just hit your zoom standard, and this will give you minus 10 to plus 10, minus 10 to plus 10. Okay. But what happens when you get that is what this thing looks like is just some straight line here, and it comes down, and you may not even see this value, this hump right here that much. But then this just goes out of sight and then just comes back. So that's not too good. Okay, that doesn't really give us a good picture. So we go experiment. Okay, so we now change the range from a minus 6 to a plus 6 and go down to a minus 200 to a plus 200. And we get to see this part, what's happening there. Okay, so you just, all right, another way, go do minus 6 to 0 and then do minus 1 to 3 by increments of 1, and we get a better picture of what's happening here. So learn to do that. When you're graphing algebraic functions, learn to go in and change your range, your window, to a lot of different values so that you start seeing what's really happening. Because too often, in big complicated equations, what happens is you see a line right here, and then this will come across like that, and then it just goes out of sight, and then it comes back. And so you're not seeing this part down here. So you go change your Y range and look for it and see what's happening. See when it starts coming back. Trace this. See what this value is right here. Go over here and look in here and see what's happening here. Okay, see that it's coming back up and then coming back and crossing it. Okay, so you must change your windows and go in and experiment and find out what happens. All right, maybe I've worked that one enough. Now let's go to example 2. Now what I've done on example 2 is take that same example 1 equation, multiplied it by 3 for the numerator, and made up another denominator, another equation thing down here for a denominator. So here's what happens when we have numerators and denominators. All right, step 1. Okay, step 1, we go take the numerator and go use synthetic division or your calculator and get it factored. So here's the same factoring that we did a while ago. Okay, we have the minus 1 root 3 times, the minus 3 root 2 times, and the plus 2 root. And then I have a 3 out here because I ended up multiplying this by 3, but that'll be a reasoning I'll point out in a minute. All right, then the denominator, synthetic division, calculator. Just go get that factored, and when you get it factored, you have this one, a root of 4, 1 time. A root of positive 1, 4 times. Even number of times. A root of minus 5, 1 time. All right, step 1. Step 1, what makes the numerator 0? There they are, minus 3 twice. Minus 1, 3 times. Plus 2, 1 time. So step 1, we found where it crossed the x-axis. Step 2, look back up here at the equation. If we let x be 0, really all it ends up being is the constant over here divided by this constant. So minus 54 over minus 20 is approximately 3. That's all we care about. We're sketching this now. We're not graphing it, so we don't have to write down the exact value of that. So it's close to a positive 3. Now, step 3. New deal. Step 3. Finding the roots of a denominator, okay, which is one of these 4s, a minus 5 1 time, and a plus 1, a plus 1 4 times. So they're the denominator roots, we might say. And these are going to be important. This is where we're going to draw our vertical asymptotes. These are where on the x-axis we're going to draw our dotted lines. And the curve's not going to ever cross those dotted lines. All right. That's the vertical asymptotes, whatever makes the denominator 0. And it's important that you write one down more times. If it comes out 4 times, it's going to be important in a minute. All right, step 4, horizontal asymptotes. Where are the dotted lines going across this way? Well, let's go back and look at, I want you to go back and look at the notes. Go back at the first page and look at the notes at step 4. It says that if these powers, the highest powers now, okay, I've got a bunch more over here, x to the 5th and x to the 4th, but the highest powers, if the highest powers are the same, you will have a horizontal asymptote at y equals this coefficient over this coefficient, 3 over 1. So we will have a horizontal asymptote at plus 3, y equals plus 3. If this power is larger up here, okay, if the numerator power is larger, then what we get is what's called a slant asymptote or some kind of a curved asymptote. And I'll talk about that at the end of the examples. If the denominator power is larger, then your horizontal asymptote is y equals 0, which is the x-axis. The x-axis. All right. Now, what horizontal asymptotes are for is for when we start graphing this, the curve out at the very far left and the far right will approach y equals 3. The curve can cross the horizontal asymptote inside the middle. What the horizontal asymptote is for is saying that this curve, as it moves out here at x equals 100, the curve will approach y equals 3. When x is a minus 4,000, the curve will approach y equals 3. Okay. So the horizontal asymptotes are for the left side of the curve and the right side of the curve, not for the middle inside of the curve. All right, now let's get after sketching this. Okay, I want to make sure you're looking back now at your notes as I talk through this too. I want you to look at step 1, step 2, step 3 in your notes as I talk about this. All right, so here we go. Step 1, where it crosses the x-axis. All right, well, let's see, we have 1, 2, 3, 4, 5. Kind of mark off that. And then up here we're going to do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. All right, now let's see. Step 1, where does it cross the x-axis? It crosses the x-axis at 2, minus 1, and bounces at minus 3. All right, that's step 1. Crosses at 2, crosses at a minus 1 because it's 3 times, bounces at a minus 3 because it's 2 times. Step 2, y-axis, approximately 3. It's a little less than 3. Now, that's going to be important for us. It's a little less than 3. 54 divided by 20 is like, what, 2.7. So it's a little less than 3 right here, 2.7. All right, now wait a minute though. Step 3 says we have some vertical asymptotes at -5. So we come over here and draw us a dotted line at -5. Let's see, at 1 we have a vertical asymptote. So at 1 we draw us a dotted line. And at 4, 1, 2, 3, 4, we have a dotted line. Whatever makes the denominator 0, we have dotted lines for vertical. The curve does not cross. This curve right over here, you see, before I would have looked at this and said, okay, it's going to come down and cross, over here it's going to cross. No, can't cross this. So what has to happen, it has to come down like this. And it goes out here, but it never touches x equals 1. All right? Well, let's see. This comes across and it bounces here, so this has got to come back here and bounce. And so this must go down like this. I got that part done. Well, let's see now. What happens inside here? All right, now listen closely. Here's a new concept. On the vertical asymptotes, if this asymptote is here, that root is 2 or 4 times, an even number of times. This asymptote is here an even number of times. Then what it says, look what happens now. At +1, we have it 4 times, an even number of times. So what's going to happen is the curve is going to be on the same side. Right? On the same side. If this curve over here had been down here, then over here had been down here. If this vertical asymptote there is 2 times or 4 times, then the curve will approach it from the same side, either both going up or both going down. If it's there, look over here at the -5, if it's there an odd number of times, then what happens, if on one side it's down, on the other side it will be up. So an odd number of vertical asymptotes, it's the opposite side. I mean, on each side it's the opposite direction. Okay? So over here at 4, okay, so now let's just zoom in on the graph and let's finish this thing up. Okay, so over here at 4, 1, 2, 3, 4, it was up here at the top and it crosses, therefore it has to approach it going down this way. All right, now then, so we kind of got what's happening inside these vertical asymptotes. What we're now going to do is look what happens on the outside of the asymptotes. And so we go to step 4. Step 4 was y equals 3 is a horizontal asymptote, okay, at y equals 3. And what happens is, let's see, now this is how many times right here? This was how many times? This was an odd number of times, just 1 time. So it was down here on this side, so on the other side, it has to be on this side. Okay, so it goes up here forever, not touching this, and then it comes down and approaches, okay, this one. All right, let's go over on the other side. Back over here at 5. All right, this time this thing comes down here and then comes back up and approaches from the bottom. Now what I want you to hear and listen to is the horizontal, this crosses the horizontal asymptote inside. It can do that. Sometimes it doesn't, but it can cross the horizontal asymptote on the inside of the vertical asymptote. What the horizontal asymptote's for is for the extremities to the left and to the right. And even sometimes here it can cross. So what we have to do is take our calculator and zoom in and just check this out. So what you need to do is set your numbers, your windows here, and see what's happening from like a -10 to a -1, 2, 3, 4 to a -4. See what's happening in here. And then just let it go from the Y from 0 to 4 or 5 or something, and just look at what's happening here and see if it's coming in like this and not crossing it, or whether it crosses and comes back to it. But at the end, over here way out there, when X is 100, it will be close to 3. Then you come over here and do the same thing for here, because we don't know where this comes down and crosses and comes back, or whether it comes down. So you can do the zooming for that process. So let's look at all this graph one more time. Here's what we're step 1. Crosses, crosses, bounces. Step 2. Step 3. Here's a dotted line at 1, dotted line at 4, dotted line at -5. That the dotted line at 1 is an even number of times. So since it crosses here, it's got to come up this way. Well, that tells me since it comes up this way on this side, it's got to come up this way on this side. So here I'll bring it down. It has to cross. So it has to go down and not touch. This vertical asymptote is just there one time, so if it's down on this side, it's going down. Over on the right side, it'll be going up. Same thing over here. -5 asymptote is just there one time, so since this bounces and it goes down here on this side, it's got to go up. And then the last thing, the horizontal asymptotes, is this has got to come down and then approach this dotted line. It may come down and approach it this way, may come down and cross it and come back and approach it. Whatever it does, that's where you're going to find out with your calculator. That, or you're going to have to plot some points. You're going to have to come over here and plot, see, this is 1, 2, 3, 4, 5. You're going to let X be 5.1 and see if it's above 3 or below 3. Then 5.2, see if it's above or below 3. And, you know, that's, if you have a calculator, just go sketch it right quick. But I'm saying to you, you need to know pencil and paper work also. Here's what's going to happen. When you plot this with just windows, you will not see this. This thing will come along here and then just all of a sudden come out of there. So you're going to have to zoom in and keep zooming in and out and finding all this. Whereas if you know the concept that I'm trying to teach you with pencil and paper, there it is. You know what's happening. All you need your calculator for is to see whether this does not cross and it approaches, or whether it crosses and comes back and approaches. The rest of it you can handle without the calculator. And what happens in the calculator here is these dotted lines, you know, this thing will come down here and all of a sudden just draw a line back up. And where that line's coming back up like that, sometimes that's a vertical asymptote and sometimes that's the curve coming back. So you need to know pencil and paper work. All right, now let's look at example 3. Let's look at now at you know, a lot not as complicated, big numbers, but it still goes through the same rule. So let's look at example 3. It says y is equal to x squared minus 6 over x squared minus 1. So what we do, step 1, set this equal to 0 and solve. Okay. Quadratic equation, whatever, factoring. So I factored it. So this tells me step 1, I have a root of a -2 and a +3. Step 2, let the x's be 0, and that tells me -6 over a -1. All right. Step 3, x equals 1 and a -1, vertical asymptotes. Step 4, go back up here. Step 4 is y equals 1, highest power over the highest power. Let me say it all one more time. Step 1, set this top equal to 0, and we find -2, 3. Step 1, our roots crosses the x-axis -2, 3. Step 2, these constants out here. Step 2 crosses the y-axis at +6. Step 3, denominator, whatever makes the denominator 0, which is a +1 and a -1. Step 4, highest powers are the same. Therefore, it's this coefficient, which is 1, over this coefficient, which is 1. So y equals 1 is a horizontal asymptote. All right, now let's sketch it. All right, so here we go. We're going to kind of mark these off as 1, 2, 3. Over here, -1, -2, -3. All right, so we'll come up here 1, 2, 3, 4, 5, 6, 8. 1, 2, 3, 4, 5, 6, 7. These units don't have to be the same length as this. All you got to do is sketch it in. What we want to know is that it crosses the x-axis at a -2 and at a +3. So it crosses here, crosses there. Okay? Step 1. Step 2, +6. 1, 2, 3, 4, 5, 6. Okay, crosses here. Step 3, we have a vertical. We have a vertical asymptote at +1 and at -1. Hey, look here. It crosses here, but it can't get over here to this one. Can't get over to that one. So we don't know where this thing comes like this or like that. So we need to plot a point, okay? We need to plot a point in here then. All right, let's see now. Step 4, we have a horizontal asymptote at y equals 1. All right, so we've got where it crosses the x-axis, where it crosses the y-axis, vertical asymptotes, horizontal asymptotes, and now we go sketch it in. Well, let's see. We need to plot a point. You know, take your calculator and do it, but let's plot a point. If we put a 1/2, a positive 1/2 in the problem, all right, if we put a positive 1/2 in there, we will get a negative on top and a negative on bottom, so it's positive. So it's positive. So it's positive. Therefore, this must be going like this. Okay, it comes down and it goes back up. Okay, what I'm saying is if we'd plugged a 1/2 in here and got a negative, then that means it's down here, and so it would have been coming over here and crossing and going up like that. All right, could have come over here. So we go plot a point, or take your calculator. Okay, and you see what happens is you get a little curve up there. All right, now let's plot a point over here. Let's take the 2. If we put a 2 in there, now look at the equation where it's factored. Let's go over and look at the equation where it's factored. This is the easy place to do that. It's real easy. If you put a +2 in here, you get a minus, plus. Put a +2 in here, you get a plus, plus. So plus, 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 minus, so it's a minus. Let's go back over and look at the graph. So that means when I'm over here at 2, it's down here. It's negative something. We don't care about the exact value. It's negative something. So that must mean that this thing comes down. Now look what happens then. Let's check everything out. This asymptote was 1 time. On this side it's down, on that side it's up. See, I could have gotten this without plotting that point. Because if it's up over here on this side, it's got to be going down. Therefore, I could start my curve and say, okay, it's got to come up here. Now, wait a minute now. Remember, this is the horizontal asymptote. Can't cross that probably, so it's probably going to go out like that. Okay? Not touching the dotted line. All right? So let's check over here now. Oh, the same rule. If over here it's on this side of this vertical asymptote, it's going on this side, then over here it's got to be down here. So this has got to come up here and cross and approach that. Now again, what you can do with your calculator is zoom in here to see if this might come up here and then come back. Come up on top and then approach it this way. What you need to do is with your calculator check that out. Alright, well that's all there is to sketching this curve. All right, let's look at example 4. And if you'll notice in example 4, it's the exact same x's. It's just the square root of it. And here's what I'm going to try to teach you from example 4 and example 5 that I'll talk about in a minute. Example 4 says if you have the square root of something, go do that something. Go do this inside, just like we've been doing it. All right? So let's go back over here. Looking at this, so we'll just go do the same thing that's inside the square root. If I have y is equal to square root of something, just go do that. And then what happens is you say, okay, I'm just going to erase the bottom. You just erase the denominator. Whatever curve is down here, you just erase it. You only get the top part, and here's the reason. If I have y equals the square root, it says y is only positive. That's the positive. I only get the y positive of the graph. Now, if I'd had a minus the square root, I would only have the negative part, the bottom part. But you need to understand that the square root of 9 is just 3, not plus and minus 3. If the square root symbol is written down, then the answer is whatever the sign is in front of the square root, not plus and minus. If I have x squared equals 9, then I have two answers. A plus 3 works, and a minus 3 squared works. But if you have the square root written down on something, then it is only the positive values. So that's why if you have a square root, you erase whatever the denominator part, the bottom part is. You just erase it, and that's the answer. So you go sketch whatever you have inside here, just like we've been doing it, and then come back and erase or don't draw wherever the y is negative. Okay, now let's look at example 5. Example 5 says, what happens if the y is squared over here? Okay. Now what happens here is you go do the same thing. You go sketch that. So let's go over and look at it. Okay. So what happens over here, you sketch the same thing. Whoa, wait a minute. Except what you do is take this and mirror image it. You fold it over. You just like a Rorschach ink block, okay? Blot. Okay? You just fold this over. And so what happens is this dotted line comes down here, and this curve comes in and stays here, and this curve comes in here and stays here, and then this comes down here at 1, 2, 3, 4, 5, 6, and plots this way. Okay, so what happens if you have y squared? Now, listen closely. To do this on your calculator, what you must do is go plot y equals the square root of it, and y is equal to minus the square root of it. You see, y is equal to square root graph. You can't put y squared on your calculator, so you graph y is equal to square root of it, and it'll go graph that part. And then you graph another equation minus the square root of it, and it'll graph this part down here. So that's how you do it with the calculator. If you have a y squared, you plot two different curves. Okay? Pencil and paper, you simply, on a y squared, you simply graph this part here, and whatever's on the top, you just fold it over, mirror image. It's called a mirror image, reflection across the x-axis. You just mirror image it down here on the bottom. Okay, now let's look at example 6. All right, looking at example 6, we now have a different case here. We have a power on top that's larger than the highest power on the bottom. So we're going to get, instead of getting a horizontal dotted line, we're going to get some kind of dotted line that slants or curves or something. So let's look at this particular case. All right, let's still go through step 1. Step 1, set this equal to 0 and solve. All right. So this factors to what? 3x and x and a plus 1 and, a minus 1 and a plus 2. And in the bottom is factored x plus 1. So we have it factored. So step 1 crosses the x-axis a negative 2/3, 2 divided by 3, a negative 2/3, and a plus 1. So step 1, we have 1 and a minus 2/3. Step 2, go back up here, let x be 0. Step 2 is a minus 2. Okay. Step 3, minus 1. Denominator, x equals a minus 1, vertical asymptote. All right, then step 4, we'll talk about in a minute. Okay, let's come over and do the first 3 steps, and then we'll go back over there and do the algebra. All right, so let's see. 1, 2, 3, minus 1, 2, 3, 1, 2, 3, 1, 2, 3. All right. Step 1, let's see, a minus 2/3 crosses, and at a plus 1 it crosses. All right. Step 2, is it a minus 2? Intercept here, crosses there. Step 3, we have a vertical asymptote at x equals a minus 1. All right. Now that looks like, hey, well, that'd come down here, cross, come back, cross, and that, that's the answer. That's about all there is to it. But no, there isn't. What we have now, let's go back over and do the step 4. Now, if we have step 4, with this power is higher than this power, then we must do long division. We must come over here and say x plus 1 divided into 3x squared minus x minus 2. So x will go into 3x squared, 3x times. 3x times that's 3x squared. 3x times 1 is a plus 3x. On long division, you change this, you subtract, change the sign, so we have a minus 4x. Bring down the next term. X will go into minus 4x minus 4 times. That gives us a minus 4x minus 4. Subtracting, change the sign, and adding, we get a remainder of 2. So we don't care about that. We now do this. Y equals this. Y equals that, and we go graph that, and that's our slant dotted line. We go graph whatever this numerator is, this answer to our division. Okay. All right, so let's come back over to the graph and look at that. So we go graph. If x is 0, y is a minus 4. So we come down here at a minus 4. Slope is 3, so that means over 1 up 3. So what we get then is a dotted line like this. We get a slant asymptote. All right, now let's see. I want you to look down here now. We have this vertical asymptote going down here, and we have this horizontal, this slanted asymptote coming up here. All right, so let's kind of back off so we can see all of this, and here we go. Well, let's see. The curve has to cross here, and it has to cross here. So let me kind of change the slope of this a little. And so what happens is this thing comes up here and approaches this dotted line, but never touches. Okay, so it comes along here and approaches this. So it comes over here, approaches, never touches. So that's part of the graph. But see, what happens is if you put that on your calculator and do the normal windows, you won't see this down here. There's another part of the graph down here, because look what happens. This vertical asymptote is 1 time. So if on this side it's going up the top, down here it's got to be coming from the bottom. And so what happens is you get a curve at the bottom like that. All right, so if the highest power on the top is larger than the highest power on the bottom, you're going to get not a horizontal dotted line, but you're going to get a dotted line in here some way that's slanting or curving or whatever. And to see that, you're going to have to change your windows and zoom in and out and see what's happening on here. Okay, so if your highest power, let's look over here at the equation. If your highest power on the top is larger, then go do long division. And then just plot whatever this equation is, and you can do that on your calculator. Plot that with dotted lines. Okay? All right, let's look at example 7 now. Okay, example 7. Again, the highest power in the numerator is larger than the highest power in the denominator. So let's see. We'll go use roots and find this. And finding this, we get factoring it. We get x plus 1 times x squared plus x plus 1 all over x minus 1. So step 1 tells us minus 1. Use the quadratic formula on this, and what you get is imaginary roots. So these two don't give us two other roots. So it only crosses at this one spot. So step 1 crosses at minus 1. Step 2, come back up here, mark out the x's, and so step 2 is a minus 1. Step 3 is plus 1. Now, what I want to do is step 4. Step 4 is I'm going to go divide this into that. So we're going to do x minus 1, x squared plus x plus 1. This is x cubed, excuse me. I'm writing down the answer, all right? This is x cubed plus 1. All right, so x going to x cubed, x squared. So x squared times x is x cubed minus x squared. Change the sign of the bottom one and add. So this is a plus x squared. X will go into x squared plus x. So this will go x squared minus x. Change the sign, bring it down. Plus 1. X will go into x one time. And so that'll x minus 1 with the remainder, 2. Don't care about the remainder. Therefore, what we want to plot is y is equal to x squared plus x plus 1 for our dotted line. All right, so let's look at all this one more time. Step 1, minus 1. Step 2, minus 1. Step 3, plus 1. Step 4, y equals x squared plus x plus 1. All right, so let's come over here and sketch this then. All right. Step 1, a minus 1. Okay, I'll make these pretty large here because everything's going to be within that value. Okay, and then we'll make this 1, 2, 3, 4, minus 1, 2. All right, so step 1 is a minus 1, it crosses. Step 2 is a minus 1. Step 3 is at a plus 1 dotted line. All right. And step 4. Step 4, y equals x squared plus x plus 1. So we've got to graph that. So graphing that, what we get is a parabola. Right. So here is a parabola graphed. Now we got to sketch it in. Well, this is an asymptote. So what happens here is this graph doesn't touch that, comes across, comes down like that. Okay? Doesn't touch this dotted line. And then over in here, we have another part of the graph. Comes up, doesn't touch this, and doesn't touch this dotted line. And where you find those is by changing your windows and going in and trying to find it. But we know this is a vertical asymptote, does not cross. And so what we do is use the calculator and our pencil and paper work to get that sketched in. So you can have an asymptote that curves. All right, now let's look at the last one, example 8. Example 8, here is already factored for us. But what I want you to see is what happens sometimes when they make up curves is that if you factor the bottom down here, those would divide out. So what you're really graphing is this. So if one of the denominator vertical asymptotes would drop out by, when you factor, would divide out, you will not get a dotted line there. Okay? So what happens on this one is, now let's go through the steps. Step 1. Okay, step 1 at a -1 and a +5. 1, 2, 3, 4, 5. So it crosses it there and it crosses there. All right. Step 2 is what? A -10 over a -4, which is 5/2. So up here at 1, 2 1/2 crosses. All right, now let's see now. Step 3, we have a dotted line at +2, but not at a -2. Not at a -2. You won't see. And that's what I want you to point out is when you go plot that and you don't get two vertical lines here, when that denominator shows you're supposed to have it at +2 and a -2, that's what happens. That -2 factor would divide it out with some factor in the numerator. All right, so only at the +2 do we have the vertical asymptote. Now the horizontal asymptote. Horizontal asymptote is dividing x cubed something by an x squared something. And when we do that, we get y is equal to x and something. So what we get then is a vertical asymptote coming across like that. Okay? So, crosses, crosses. So what happens? This thing curves like this and comes down, never touches on that side. All right, what happens on this side? Well, where it crosses here, it comes down. Excuse me. This is exaggerated here. Okay, but out here, it won't touch that. Comes down, won't touch this one. Will not touch this dotted line. Will not touch this dotted line. Now, one other thing that I want you to know about here is the factor that we took out when x is a -2, for the factor x plus 2 in the denominator, it factored out, which means you will have a gap in the curve. Right here at x equals a -2, there will be no graph there. And you won't see that blankness there. But if you'll zoom in about 11 times, you will notice that it's not a smooth curve there. It does not have a dot at x equals -2. Okay, we're not going to worry about that. This is the concept here. Okay, this concludes pretty well the different concepts that you need to know about sketching algebraic functions.